So next we have Angel Rivera. So there's a lot of talk about Kubernetes, but if you don't understand containers or how to use them, it makes using Kubernetes pretty difficult. So in this talk, Angel's going to be talking about the different things that you need to know with containers and how to successfully adopt and operate Kubernetes. So off to you, Angel.
Thank you, Tiffany. And I want to welcome all of you to my talk today. As Tiffany mentioned, this talk is geared more for folks who are just getting started with Kubernetes. And what I'm going to talk about today is some of the things that you need to know or should know before getting started with Kubernetes to ease that whole process for yourself. So here's a quick agenda of what I'm going to be talking about today. And my name is Angel Rivera, developer advocate for Circle CI. And in my daily role as a developer advocate, I basically engage the community, learn how people are using technology, also mentor folks or give advice to folks who are using certain technologies, especially in the fields or the technologies that I have experience with. And what I do is gather all that information from the community, bring it back to our teams at Circle CI. And we use that information to build features that are valuable and meaningful to our developers and the developer community as a whole. One of the things I wanted to mention here is if you want to reach out to me after this, obviously we're going to have a Q&A, but if you want to reach out post-conference, my Twitter handle is @punkdata, and I'm pretty much available for any kind of discussion. So please feel free to ping me on Twitter if you ever want to talk. So let's jump into the word Kubernetes, or the term K8s, I should say. When I first started getting involved with Kubernetes, I was seeing the term K8s, thrown around in presentations, documentation. Wasn't quite sure what that meant. So I like to start off any Kubernetes conversations with defining what K8s means. And basically, it just the K8 stands for Kubernetes. And the number 8 is just represents the characters between the letter K and the letter S in the word Kubernetes. So it's just that simple. I'm also going to be using that acronym quite a bit in this presentation, so I just want to kind of level set everyone with that. So first thing I want to ask is, why Kubernetes? Why do people, find themselves learning Kubernetes or trying to get started with Kubernetes? And I want to share some of the common reasons why, common legit reasons why people would want to start getting involved with Kubernetes. So in the age of DevOps and continuous integration, continuous delivery, and the multitude of automation that's out there, software development teams are building software and releasing it as really, really quickly these days. So that means that the processes are changing on the back end, so their practices and principles are changing, and they need tooling to help facilitate those practices and principles. And Kubernetes is one of those tools that actually can help facilitate the software development lifecycle the way we're doing it today. So if you want to build software faster and help facilitate some of the practices and principles that you have in your software development cycles, definitely look into a tool like Kubernetes to help facilitate that. Also, I've been hearing quite a bit of confirmation that by implementing Kubernetes, it helps cut some infrastructure costs. The reason why you would achieve some savings there is because Kubernetes does a lot more with less. And the reason why it does a lot more with less is because it has capabilities that are suited for requirements such as high availability and elasticity or scalability of your application and services. So Kubernetes is a very complex, robust system that helps in these two primary concepts or genres, right? Teams want to make sure that their software is highly available, and as well as being able to meet the demands, right, as needed, which is the scalability portion of this. So let's jump into a quick introduction into Kubernetes. I like to just kind of cover the critical elements of Kubernetes so people understand what it is that the platform is and what it's not. So here's a definition of Kubernetes. But the main thing I want you to take away from this definition is the fact that Kubernetes is an open source container orchestration system. It's really important that you understand that it's a container orchestration system because without containers, right, Kubernetes is pretty much just a bunch of services running and wouldn't be able to serve anything. So, again, Kubernetes is an open source container orchestration system. Now, let's talk about how deployments have evolved real quick, because it is pertinent to the Kubernetes conversation. So, let's take a walk back memory lane, right, to traditional deployments. If you look to the left, we used to deploy our software or our applications to straight up bare metal iron, right, systems. So at that point, the stack was just hardware, operating system, and then your application with a couple instances running on that same hardware. Now, the problem with that traditional deployment was when you had to scale, right? So if you had a popular website or service, and once you started getting some demand on that, you had to, provide more resources. And when you provided more resources, that meant you had to install and provision and configure and maintain a whole new server, so to speak, right? Or more hardware, more operating systems, more to run those instances of your application. Obviously, we did that for a couple years, but we as engineers, as a technology industry, we got smarter about this. And we figured that, hey, we're not utilizing all those resources on the hardware and the operating system efficiently or optimally. So that kind of brought on the advent of the hypervisor, which, if you look to the middle, you see the virtualized deployment. The hypervisor basically is a software layer that sits between the application and then the underlying operating system and hardware. So now you're able to, with the hypervisor, you're able to manage those underlying operating system and hardware resources a lot smarter. So the hypervisor, optimizes the resources. And then on top of the hypervisor, we added a layer which we packaged up the application to what we call a virtual machine. That virtual machine provided some isolation features, right? So now you can run multiple instances of your application in one package. But the problem with that was a little heavy, right? So you had to install an operating system, you had to install the binaries, all the libraries, and then your application, and they ran isolated. And that worked really well for quite some time. The problem is, we got faster as a technology or as an industry. And fast forward to today where we're doing container deployments. Now, if you look in that diagram, what has changed is the hypervisor has been replaced with the container runtime, which again is another software layer, right, that communicates with your application and then the underlying hardware system. And it actually manages those resources, just as good or if not better than the hypervisor. Also, if you look on top, we're now running things in a container, not a virtual machine. With those containers, though, they're a light footprint. Again, gain that isolation, and it just uses the underlying resources via the container runtime. So now you can package up what you need for your application and not the whole operating system, plus all the other bits, right, that you need. So let's take a look at Kubernetes in a kind of decomposed sense. So the top object or layer of Kubernetes is what we call a cluster, I'm sure you're all familiar. A cluster is a group of machines that are basically working in unison to provide a service or a software application. Uh, and as such, if you take a look here, you can see to the left, we have what we call a Kubernetes control plane. So think of that big block there as the control plane as one server or virtual machine or whatever compute resource you use. And then the other to the right, the Kubernetes nodes are basically other servers that are part of the cluster. The differentiating point here is the Kubernetes control plane is actually the brains of Kubernetes, or it is Kubernetes, and it has all the services running on there. The Kubernetes nodes or worker nodes, as we call them, are basically the horsepower for your cluster. So all of the containers that you run basically run on these worker nodes. And again, I just want you to understand that the Kubernetes control plane is kind of the brains of Kubernetes, or it is Kubernetes. And then there's services that are installed onto these worker nodes that actually communicate back with the control plane servers. So again, it's a kind of it's the way that the cluster is composed and managed. So as I mentioned, right, the Kubernetes nodes are referenced as primary or control plane, and again, here's another diagram, similar. You could see where all the services are running and the different services. But if you look away from the primary node, you look to the left and you see the other nodes, right? The Kubernetes nodes. You can see that all of them have the container runtime running. That's the most important piece here to understand, right? And the reason is, again, those uh, Kubernetes worker nodes are where your containers are running, and they're running in pods, which are basically a grouping of containers. So you can deploy, let's say, 3 instances, right, or 3 containers of the same application on a worker node, and it'll be grouped into what we call a pod. So that's kind of like the lowest level of a Kubernetes object in the system. And again, right, just talking about pods, just understand that they are basically your containers, a grouping of your containers, right? And they're labeled so that they're easily managed and accessed, right, through the Kubernetes services. So the most important piece to Kubernetes is the container runtime, right? Again, it's a container orchestration tool. So obviously, right, the container runtime is the most important service in the entire Kubernetes cluster, because without it, you have pretty much just a Kubernetes system, right, not running the containers that it's supposed to be running. So I like to talk about some skill sets before we get into the container runtime in Docker. That I like to talk about the skill sets that I believe folks should invest in, uh, either previous to their Kubernetes interaction or engagement, or during it. Because when I first started, I went through it all, and it was painful because Kubernetes is a complex but very robust system. And if you don't have all the, I would say, or if you don't have certain skills or knowledge, it becomes a lot more difficult and frustrating to actually tackle Kubernetes as a newcomer. So the first thing is, if you're not familiar with continuous integration, continuous delivery, or DevOps practices or principles, I definitely recommend that you invest some time in learning some of the foundational concepts of these software development practices, because what you'll learn is how folks are building, securing, testing, and deploying their software in modern day software development, the way we're doing it today. These practices and principles are commonly adopted and implemented on teams, and it's definitely something that will help you when you're, especially when you're having discussions about how to release software in the Kubernetes context. Another skill is definitely understanding security, of course, but being more specific, role based access controls is a very good starter for, especially when you're working with Kubernetes, because that's one of the security paradigms that Kubernetes implements. So give role based access controls a look, as well as all any other related type of security concepts. Again, you don't have to be a security master at this stuff, but at the end of the day, you need to have some foundational knowledge to understand how the platform is actually secured. Networking fundamentals. This is really important as well. Because you're running multiple instances of multiple applications, you could be doing that in a lot of different clusters, right? Networking is critical. Understanding the fundamentals of networking is critical because the underlying platform relies on that. Kubernetes is basically again a robust system that can stand up web applications and stuff and services. So if you're doing that, and you're standing up web apps, you definitely need ways to expose, right, your application to the public via IP addresses or DNS, domain name services. So definitely, have an understanding of Kubernetes and its capabilities. This will help you be less frustrated, so to speak, when you're first learning Kubernetes. Monitoring, logging. As developers, we're pretty much used to logging. I would, it's safe to say that. But if you're not familiar with monitoring or observation tools, definitely invest a little time in understanding how all that plays together. Because again, Kubernetes is a complex, robust system, and having skills in monitoring and logging and understanding how that all plays together within the platform will definitely benefit you when you run into issues, right? When you're trying to troubleshoot what's going on with your application in a Kubernetes cluster. So definitely give that a look and gain some knowledge in that arena. Storage. So there's going to be times where you're going to want to store information within the Kubernetes platform. In this case, I would just recommend, understanding kind of like block storage, what that is, and how it interacts with Kubernetes, how Kubernetes interacts with the various different block storages. Sometimes we're going to deploy Kubernetes into like a cloud provider, and no cloud provider is equal. So like the storage bits are definitely different and consumed differently in different platforms. So just have an underlying understanding of how Kubernetes integrates with storage and handles and manages any kind of persistence layers that you need. Definitely have an understanding of APIs, application programming interfaces. Again, as developers, we're probably pretty familiar with this concept, but I would focus in on the Kubernetes APIs. Kubernetes was built as an API first platform, so that's really really cool. So and you can get to pretty much any kind of service programmatically. Again, just have a basic understanding of the Kubernetes centric APIs, so that will ease your transition into learning Kubernetes. YAML. YAML is a data structure that is commonly used in the cloud native universe or sphere. Learning YAML, learning what it is, learning the limitations of YAML will definitely help you not only with your Kubernetes experience, but also, it's a skill that you'll definitely use throughout your cloud native journey, or as a developer in the cloud native world. Infrastructure as code's also one of these key skills that I believe everyone as a developer should start learning. It's kind of the new hotness. It's kind of becoming the standard, and this is where we're codifying infrastructure. And instead of us going through a GUI, point and clicking, and creating infrastructure, we're definitely just again codifying our infrastructure and resources so that it's reusable, repeatable, consistent. So definitely jump in on and learn some of that. And finally, you definitely need a deep understanding of containers. As I mentioned before, Kubernetes is a container orchestration system. So without containers, you pretty much got nothing, right? So jump in on that. So let's talk about Docker and what it is. As I mentioned earlier, right? It's almost like I like to define it as a new way of packaging your software, right? When we were dealing with Docker and containers. So let's go ahead and look at Docker. The main focus here is going to be the Docker engine. That's actually the nuts and bolts to the whole container world, right? And Docker is the engine itself. Here's a nice little diagram. If you notice the blue boxes around the edges, those are the ways that you can interact with the Docker engine, right? So Docker engine or client or runtime is just some software that can run on a laptop or a server. And again, right, it's the underlying engine for Kubernetes and your containers. And as you can see, right, you can interact with it through an API programmatically, the Docker CLI, which I'll be demonstrating a little bit in a minute. And then you can actually extend that Docker engine, right, with plugins. But if you look at the core, you see that Docker build box there, as well as networking, right? So you can see there's some of the skill sets that I recommended you learn earlier are kind of coming into focus here in this Docker engine visualization. So there's two components to Docker. The first component I'm going to talk about is, as a developer, the two components you need to learn are images and then containers themselves. So what I want to talk about is images. Images are basically the templates for your Docker containers. So I like to use the cookie cutter analogy. Imagine a cookie cutter That's basically equivalent to a Docker image. And let's say you had some dough spread out on a table. You push down, right, with that cookie cutter template, and you make a cookie, or you cut out a cookie. That is equivalent to spawning a container based off of a Docker image. So I hope that analogy works. I've used it a few times, and some folks tell me it's pretty good. But basically, a Docker image is the template, right? It's the blueprint for your container. And the way you would build an image is by leveraging the Docker build command, which is, again, one of these really important commands you need to learn. And it's specific to building images, right? So you would only use this to actually build a Docker. And how you would define that image is through a Docker file, right? And a Docker file is basically, and here's an example of one, is basically a file in your project. And it just has all of the directives and instructions for how to build this image. As you can see here, the first line is from node 12, which is basically all. I want to also mention that Docker is layered and cached. So what you're doing with that first line is inheriting from an existing image that lives in an online repository called Docker Hub. And then from there on, right, you're just creating some required directories, copying over your package .json file so that you can then install your application's dependencies. And then the final lines there with the copy command, just copying your source code over. You're exposing port 5000 on that container. And then you're telling it whenever this container is spawned, run this command with the CMD syntax there. So again, Docker images basically are templates for your Docker containers. And when you want to create a container, you want to use the Docker run command. So Docker build and Docker run are the two main commands that you should focus on when you're learning Docker and learning about Docker. I don't want to boil it all down to just those two commands, but essentially, as a developer, those are the two main commands you're going to interact with, right? When you're working with the Docker containers and Docker images. So let's jump into a quick demo so I can show you how easy it is to build. First thing I want to do is show you my Docker file. It's the same file you saw in that previous slide. But I want to just show you, right, again, what it is that we're going to build from. This is the actual project. So I'm going to jump over to my terminal. I'm logged into a server, and I'm in that project, right? So let's go ahead and do a Docker image. All right, Docker images. So first thing you want to do is see what images you have. So if you type Docker images, that's basically your image, right? The list of images you have on that machine. So let's go ahead and do a Docker build command. So I did this earlier, and there you go. So what we have here is a Docker build. The -t is a tag, right? So I'm going to name it with this tag, and then I'm giving it a file flag, and then the name of the Docker file, and then this dot. This is very important. A lot of folks forget that dot, and that's basically an execution kind of trigger for Docker, the Docker build command. So let's go ahead and click that, and as you can see, it's just going through my Docker file, right, and executing all the steps in it. And it's right now in the download installation of npm. And this won't take very long because it's not that big of an application. But at the end of the day, you definitely want to have those, have those instructions inside your Docker file. Now, as you can see, it was created. If we go up, we can see now that we have a demo app image. Now, let's spawn a new Docker container based off of that. So we're going to call it Docker run command. Then we're going to do a -d to tell it to run as a daemon. Then we're going to give it a port. So it's a web app. So I definitely want to open up a port so you can get ingress traffic. And then, so it's an external, and then it's like a NAT or a network address translation for ports. So we're going to say ingress 5000 and then connect to the app in 5000 on the internal side of the container. And then we're going to give it a name. And then we're going to call this, let's just call it, I don't know, app01. And then from there, finally, you need to just tell it which image to use, right? So we're going to call the image to use is demo app. Now, we've got that container built and running. So if you want to check on your containers, let's go ahead and Docker PS, and you have the application running. So that's well and good. Let's go ahead and jump over to a web page and show off the application. Oh, 5,000. All right, the server is UB Docker, and there it is. The application's running. So let's go ahead and finish this up, wrap it up. I went a little longer than I wanted to, but so a little trouble with my slide deck. Let's see here. All right, sorry about that. So let's do a quick recap. These are the Docker commands for building an image. Go ahead and look at some of the container run commands that you need to build Docker containers, get them started, stopped, and running. And then again, here's a recap of all the skill sets that I believe you should learn in order to have an easy transition into learning Kubernetes. Here's some more resources for those of you that are looking to learn more about Kubernetes. And I want to thank you all for attending and apologize for any snafus. And if you want to reach out to me, Punk Data on Twitter. Thank you.
Thanks. That was super awesome. Like, I've been using Kubernetes and containers for a little while, but there's always new things to learn. And I think this is especially great for all those people that are also trying to just learn all this, maybe for the first, second, third time or whatever. Anyone that has questions, feel free to head over to the Q&A right now. Or also there is the Slack channel for this session as well.